Going to explain how to design a 3D model of a tail wing. So this is the final tail design. So that is main element and this control surface. So first I have created the solid ribs at different location. Then I have created the surface. Similarly for this control surface, first the solid ribs, then surfaces. Then this main element and the control surfaces, I am joining it together using the assembly. Actually this design is inspired from the Cessna 172 aircraft tail model. So this one, so I am trying to create almost closer to that original model, and this is the worksheet. So first we have the aerofoil, that is NACA 2408 aerofoil, and we have two circles and elongated hole. All the dimensions are given. Once the aerofoil is created, then we are creating the plane at different location, 232, 1750, around 6 planes totally we have. Then all those we are copy pasting this single aerofoil at different plane. Then we are changing the scale. Then we are converting the 2D profile into a solid rib section. Then on the rib section from the top view, I am drawing this profile. Then using pocket, I am removing the material within the profile, outside the profile, so that I can say this as the main element and the control surface tail one, so that finally I can get two halves. Okay, the front part and the rear part I can get it. Then I can assemble it. The same thing I am showing here in the step-by-step procedure. First, all those aerofoils, I have changed the chord length, scale, everything. Then I am converting that into a solid ribs using pad option. Only here I am using the multi-section solid because both sides we have two different profiles. Once the ribs are ready, from the top view I am drawing this profile. Then using pocket, I am removing the material outside first. Then I am saving this as the main wing. Then the same profile, if I remove the material inside this profile, then outside will be, I can save this as a rear part. So if I remove, I will get only the front portion of the aerofoils. So this I am saving as the front part. I can create the surface on it. So this will be the front part of the tail wing. Then using the same profile, if I reverse the pocket direction, I can remove the material in the front. Only the trailing edge portion will be there. So there, with the little modifications, I am creating the surface. So this will be my rear part. Then we can assemble it together to get the final tail design. So now I will see how to design this tail wing. So first step is creating the aerofoil. So we are already familiar with this airfoil creation, that is how to import the coordinate point, then how to create the surface profile, etc. and all. So straight away I am taking this airfoil profile, and even this inside circles elongated hole also I have created for the given dimensions. While creating this profile, only one thing you have to keep it in mind, that is the auto constraint issue. When you are creating this circle and keyhole profile and all, you see I am trying to create one circle. There are a coincident constraint with that point, then coincident constraint with this circle center point, then there is a tangent, like that. Lot of auto constraint will be there, that you should avoid it. You see somewhere here I am selecting, so there is no auto constraint. Then when you expand the circle also, lot of tangency constraint, coincidence constraint is coming, so you have to avoid everything. So I have taken it out. Then you can give what is the required diameter and what is the vertical and horizontal distance with respect to the axis, everything you can fix it. So this way you can create all this internal profile. So our first airfoil is ready. Now we have to offset the plane at different location. Then you can copy paste this profile, then we can change the scale. Maybe I'll keep this side by side. So first plane is at 230 using reference toolbar. In the plane tool we have to create the different planes. So first is at 230, then second plane 270, then third plane 850, then fourth plane 1590, then the last plane 1750. So now we have created all those planes with the required distance. Then we have to do the copy paste of the same profile at all the planes. So we know we should not copy from this window and paste it in the plane. You have to do the operation in the tree. If you try here, sometime these planes will be hidden. So we are always copy pasting this profile using the tree. So copy the sketch 1, then paste it in the plane 1, plane 2, plane 3, plane 4, plane 5. So all those profile we have created. Now we can go for the scaling, and you see it is moved in the forward direction 30, 39, 120, etc. and all. And here I have mentioned the scale in this small box. First aerofoil scale is 1, the next aerofoil is 1.095, like that. Different scale I have given. So we will change the second aerofoil. So select the profile using the scale tool. I'm changing this to 1.095. Then I have to offset from this leading edge to 30 mm. So this profile is ready. Then the third profile, so select the profile, change the scale with respect to this leading edge. It is 1.111. Then move the profile to 39.05 in the forward direction. Then next to profile, to select the profile, scale is 1.35. Then it has to be moved to 120 mm from the leading edge. Then this one, is with a scale of 1.65. Then the forward position is 230. Then the last profile also same size and same distance. So about the leading edge, it is 1.65. Then about that same leading edge, it is moved to 230 mm. That's it. Now you have created so all those profiles. Then we can go for the solid rib creation. So the first airfoil is thickness 10 mm, then the fourth one is 10 mm, fifth also 10 mm, last one is 20 mm, and here I have just joined two profiles. So those two profiles are with a different scale, so we cannot use pad, we have to go for the multi-section solid between these second and third profile. So first we will create the solid for the remaining profiles. Go to the part design. So this is 10 mm and this is 10 mm. This is also 10 mm. And the last one is 20 mm. So we have made all those profiles. Then between these two we have to create the multi-section solid. But while creating, we know we have to take only one closed profile. Whenever you are doing some 3D operation, it can be done between only one closed profile. But here if you see, if I select this airfoil, there is a 2 circles, then elongated hole, then another one airfoil, like that multi profiles are there. So if you want to do the multi-section solid, either you have to remove these internal profiles, or we have to create all those profiles in a separate plane. So how we have to do it means, for example, this profile I am taking, first this circle I am just cut the profile, then you can take the same plane, go to sketch and just paste it. Okay, now the circle is in different plane, that is in the same plane itself we can create infinite number of planes over and above. Then now this circle I am removing, just cut, select the same plane, go to sketch, then paste. Now the selected hole you cut in the same plane, go to sketch, you can paste. Now we have different profile. Okay, it is not a single profile. Same procedure you can do it for this another profile also. Cut and paste. So now we can try the multi-section solid. You can see, you can give multi-section solid between these two airfoil profile. Then we can use removed multi-section solid between these two circles, because these circles are with a different dia. If it is the same dia, easily you can go for the pocket. Then between these two elongated hole, then between these two circles. That's it. Now we have created all those solid ribs. Then we can go for the top profile to cut this single airfoil into 2 halves for the front and rear part. So I am taking this top view. So this profile only have to draw it. So actually it should be now it is almost in the same orientation. Now it will be easy for you to understand while drawing. So I am using the profile tool. So somewhere in the front it started and it goes like this. So later we can give the proper dimensions. First I am drawing the just outer profile. So the profile is completed. Now you can give all the constraint and dimensions. So first the constraint is it should be coincide with this plane. So already there is auto coincidence. So this is done. Then distance between these two they have given us 200. Then length of this line they mentioned as 240. Then thickness of this small length is just 20. Then length of this one is just 10 mm. and it coincides with this outer plane. Then the length of this line is 50. Then we will zoom. So here they mention from this leading edge to this edge is 750. So we have to select this leading edge, and this point it should be 750. Then similarly here, so they mention distance between this one and this one is 150. Okay, so now we have given all those dimensions mentioned in the diagram. So in the front it is extended, so it won't affect because we are going to cut the material for this solid part. Okay, we are going to material for this solid part. So if you want, you can align this exactly with this leading edge, or it can be extended also, it won't affect. So now our profile is ready. Now we exit. Better I am saving this as one separate part, maybe tail wing profile like that. Then now remove the material. For this profile, use mirror extend on both sides, just to give 200 or 100. So now what happened, we removed the front portion, only the trailing edge portion is there. So this I can save as the tail wing rear part. Okay, rear part is saved. Now same pocket operation, this time reverse side. We can use just 200 on both sides with a mirror extend. Now you see rear portion is removed, only the front of the airfoil is remaining. This I am going to save as the front part. Okay, now we will finish this front part because it will be somewhat easy. Then you can go for the rear part. This I will rotate. Okay. So all those ribs are ready. Now we can create the surface between these airfoils. Then there will be two holes to assemble the tail wing. So here it is. So there is a hole of dia 10 mm, and from this vertical line to the center point is 10 mm, and vertically it is at a equidistance point. Okay, so in both rib section we have to create a hole of 10 mm, so the tail wing can be, tail rear part will be assembled within this. So okay, now we will create all those surfaces, then we can make this holes also. Or if you want, first you make the hole. So select one surface. So here I am making a circle of dia 10 mm. Then from the center point to this vertical line is 10 mm. Then equidistance point, that is so first I have to select both edge corners, then by pressing control, then the center point, then in the first tool you have to give equidistance point. Okay, first you have to select both edge points, then the center point. You have to press control while selecting all these points. Then in the first tool you can give the equidistance. So first profile is made I can remove the material for that profile. So material is removed. Similarly, here you have to make better. I will create it on both this side and that end, so that in the plane it will be easy to view. So I am selecting this surface. So the surface is visible. Here I am making the circle of dia 10. The distance between this center point and this vertical line is 10. Then equidistance point, you can rotate, because mistakenly you should not select any other corner. You rotate. If you want, you can little bit zoom. Now I am selecting by pressing Ctrl these two outer edges first, then the center point, then constraint defined in a dialog box is opened, the equidistance point. That's it. Now you can remove the material. Now we can create the surface. So for the surface creation, you have to go to Start, Mechanical Design, Wireframe and Surface Design. In that, I am going to use the multi-section surface. So I am going to create between these two first upper curve. Similarly for the other profiles, all the upper curves I am going to select surface between these two upper curve. Then between these two upper curves, then from here to here. So the upper surface is over. Now you can go for the lower portion. So between here and here, so lower surface also completed. Then we have to go for the filling of this rear side. So you can use the fill tool. So this is the fill tool. So I am selecting all four edges and fill it. Similarly here, these four edges, while selecting, either you select it in the clockwise direction or counterclockwise direction. Okay, don't select randomly upper one, side one, like that. You don't select, either clockwise and anti-clockwise. That is this line. Clockwise means this line, then vertical one, then again horizontal, then vertical, like that. So in the order you have to select, otherwise sometime it will show the error. And here also we can fill. And at last, a small portion. That's it. The front part is ready now. So already we have saved this as a front part. So simply I am saving this. Okay. So holes also made. Now we can go for the rear part. Okay. So this is ready. So next I have opened the rear part of the tail wing, which we have already created. So we have all the ribs, solid part of the ribs. Now we have to make surface on it. Before that, I am going to make the holes to attach this rear part with the front part, and we have to make the hole in the second rib, also the last rib, same dimensions, whole diameter of 10 mm. Then from the leading edge the distance is 10 mm. Then we have to give equidistance point. Same procedure. So first I will create this two holes. Maybe first here I will try. So I am drawing one circle of dia 10 mm. Then the distance between these two is also 10 mm. Then I have to give equidistance point. So to select the point, this dimension should not cross that point, otherwise it will not be visible. So you just bring it in the bottom. Now you can pick the point. So this edge, then this edge, and then the center point. Now you can give equidistance point. So this hole is made, that is profile is made. Now using the pocket we can remove the material. Similarly, so here I have to make. So the profile is here. So I am drawing the circle. Then distance between the center point and this vertical line, 10 mm. Then we can give equidistance point. So I have selected all 3 points using control, then equidistance point. Now we remove the material using pocket. That's it. We have made both hinge points to connect this with the front part. Now we have to convert all the flat faces into a curved one, so that after attaching this rear part with the front part, when you move this up and down this control surface, these sharp edges will not hit the front part. So without any disturbance you can easily move that if you make it curved. And normally to convert this sharp edge into a curved one, we will use the edge fillet. But if you are using the edge fillet, you should know what is the required radius. Okay, so that if this is the defined profile like a rectangle etc., you can easily find. This is the profile we got it by cutting in between somewhere. So if you want to find, then you have to use this measure item tool, then you have to find what is the height, then you have to define the radius etc. and all. So that will be a little longer procedure. Even here in the exercise sheet, the radius is given at different location. So but instead of this radius and using the normal edge fillet, the same edge fillet tool, if you expand, you can find the tri-tangent fillet. This will be very easy. So this one we will try. Okay, expand the edge fillet, and the last tool is tri-tangent fillet. In the tri-tangent fillet, we have to select the two faces to be fillet, then which face we have to remove. So always we have to remove the vertical flat face. So for example, maybe we will start from here or any one end. So the upper surface and lower surfaces are faces to fillet. Actually here we have to use separately. So first we have to convert this flat as a curved, then we have to go for this another flat surface, and this vertical face is the faces to remove. Now you OK, So software automatically calculated what is the required radius and it is converted. Okay, so this will be easy. Instead of defining the radius etc and all, it will be very easy. The same procedure here. Faces to fillet is upper and lower surface. Then faces to remove is this flat surface. Give OK. Similarly, everywhere you can give faces to fillet is upper and lower surface. Then faces to remove is this flat surface. Like that, you can continuously give for all the ribs. See this profile, if you take all other ribs are, we made it using the pad. That means it will have a constant cross section, so we can easily make the edge fillet. But this one, if you see, we made it using the multi-section solid. So here the airfoil is of different section size, here the airfoil is of different size, and in between also it will be keep on varying. It is not constant. So in these cases and all, you have to use separate radius here, then here. For all four edges, separate radius you have to give. So in that cases, instead of the edge fillet, you can use this straight tangent fillet. It will be very easy. That's it. We have made all those rear ribs. Now we can create the surfaces. So you have to go to the mechanical design, wireframe and surface design. So use the multi-section surface first from here to here, upper surface, then this front curved surface. You have to change the arrow mark. So here and all we have given the tri-tangent, so that as a single profile we have easily selected. If you have used the edge fillet, then there should be a two curves, so that will increase the number of operations. So the tri-tangent is very easy method for this one. Similarly in the bottom surface. So this is created. Then between these two ribs, then for the next two ribs, here you have to check this arrow mark direction. If it is tested, simply you have to select that. You can change the direction, then it will be coming properly. Then for the last rib, actually we have to remove some portion as mentioned in the diagram. Actually before creating this surface it has to be done. So okay, we will do that. Now this is the tail portion, but here there is one inclined cut. Okay, so that you can see from here. You see it is not the complete rib. They have removed the material for this triangular profile. Okay, triangular of 400 mm, so that finally you will get a slant edge instead of the straight edge. The same thing is given in the Cessna 172, so we are trying to create the same one. So for that, this upper and below surface alone we will make it later after removing that certain portion of this rib. So select that top surface, top view. So it should be a right angle triangle, and they mentioned this distance is 400 mm, and it should be aligned with this face. Then this should be aligned with this line or that edge point. Yeah, that's it. So and this also has to be aligned with this. So now the profile is ready, and in the part design we can remove the material using pocket. That's it. Now we can fill the remaining surfaces. So you have to go to start mechanical design, wireframe and surface design. From here to here, similarly in the bottom side. Then between these two, even you can use fill also. So now the rear part of the tail is created. This one we can assemble with the front part. So already we saved it in the same name, rear part. So simply I am saving this file. So now we will go to the assembly window to assemble these two parts. So first I am importing the front part. So this is the front part. So fix this component. So now this is ready. Then import the rear part using existing component, showing the name automatic rename. So this is also imported. Using manipulation tool, you take this along the x-axis. Okay, now we can do all the constraints. So first one is aligning these two holes by using the axis constraint. As it is very small, you have to zoom a little bit. So this is aligned. Okay, as both axes are aligned in the same line, so one axis alignment is sufficient. Then we have to do some contact surface or some offset constraint. Otherwise what will happen? So in the x direction it will not move, but in the y direction along the axis it will move here and there. So to arrest that, we have to give the contact constraint and offset constraint. between any two faces, maybe from here and here, so that it will not move in the y direction also. So I will give maybe offset constraint. I'm going to give actually there will be some small gap, but as of now I'm just giving 0. So these two faces I'm giving 0, then update, and that's it. So now if you try with constraint, so before that, if you want, we can hide all those planes for the better view. Edit, search, and the type, then select the plane, then search, all the planes are listed here, then select everything, then right click and hide, and all those constraints we can hide it here. So now it will be easy to visualize. Along the y direction also it will not move, z also it will not move, only it will rotate about these hinge points. Okay, we can go for the positive and negative angle. So this is actually about the y axis, we can rotate it.